Hello students, today in this video we will see how to plot a curve and the equation given is an explicit relation. The equation of the curve is ay square is equal to x square into a minus x. Now as per the rules which we have seen for tracing a curve, the first one is the symmetry. Now you can see in this given equation the power of y is 2 and the power of x it will be 2 and 3 if we solve this bracket. So from this we can say that the curve it is symmetric about x-axis because only the power of y is even. For x it is not even. So the curve is symmetric about the x-axis. Then comes the points of intersection. First we'll find the points of intersection for the origin, that is whether the curve passes through the origin or not. We'll put x is equal to 0 and y is equal to 0 in the given equation. So what we have is ay square is x square a minus x. So we'll have a into 0 is equal to 0 into a minus 0, that is 0 is equal to 0. That means the curve passes through the origin. Then comes the coordinate axis. First the x-axis. To find whether the curve intersects the x-axis, we'll put y is equal to 0 in the given equation. What we get is a into 0 is equal to x square into a minus x. That means 0 is x square into a minus x. That means x square is 0, or that is x is equal to 0, or a minus x is equal to 0, or x is equal to a. Therefore, we can say that the points of intersection with the x-axis, they are 0, 0, that is the origin, and a0. Then the y-axis. To find the points of intersection of the curve with the y-axis, we'll put x is equal to 0 in the given equation of the curve. So we get ay square is equal to 0 into a minus 0, or ay square is 0, that means y is equal to 0. That means we can say that the curve intersects y-axis at 0 and 0, that is the origin. Now we'll find the equation of tangents. Now first at the origin. This is the given equation of the curve. Ay square is x square a minus x. We'll solve it. It's ay square is equal to x square a minus x cube. Now to find the equation of tangent at the origin, we will equate to 0 the lowest degree term in the equation. Lowest degree term is which? For this it is 2, for this it is 2, and for this it is 3. That means ay square and this x square y. So we'll take this x square y on the left hand side, and what we have is ay square minus x square a, and that will equate to 0. So that means what? Y square is x square, or y is equal to plus minus x. These are the tangents to the curve at the origin. That is y is equal to x and y is equal to minus x. These two lines are the tangents to the given curve at the origin. Now, we also know that the curve intersects the x-axis at a0. This is known as the special point. Now, we have to find the tangent at this special point, that is a0. For that, we'll differentiate the given equation with respect to x. So what we have? It is ay square is equal to x square a minus x cube. Differentiating with respect to x, we have 2ay dy by dx is equal to 2x a minus 3x square, or dy by dx is equal to 2xa minus 3x square, this in the denominator, upon 2ay. So now we'll find the value of dy by dx at a0. So it will be 2, for x it is a into a minus 3a square upon 2a into 0. It is minus a square upon 0, that is infinity. And we have seen the rules, and as per the rule, when the value of dy by dx at any point it is infinity, that means the curve has tangent parallel to y axis. So this was regarding the tangents. That is, we have tangents at the origin which are y is equal to x and y is equal to minus x, and at the point a0 the curve is having tangent which is parallel to y axis. Now the asymptotes. First we'll find whether there is any asymptote parallel to x axis. For that, what we'll do, we'll equate the coefficient of highest degree term in x in the given equation. This is the given equation of the curve. The highest degree term in x, it is x cube, and its coefficient is minus 1. So we'll equate minus 1 to 0, but this doesn't make any meaning. We can say it is meaningless. That means there is no asymptote which is parallel to x axis. Now we have to find whether there is any asymptote parallel to y-axis. Again, here we'll equate the coefficient of highest degree term in y to 0. The highest degree term in y is this, ay square. So the coefficient of y square is a. So we'll equate a to 0. But since a is a constant, it cannot be 0. So this is also meaningless. So we can say there is no asymptote parallel to y-axis. And the last one, we'll find the region of absence. That is the region where the curve doesn't exist. We can write the equation of the curve as y square is equal to x square into a minus x upon a. We'll check. Now when x is 0, y square is 0. That means the curve exists for x is equal to 0. Now if x is less than 0, this term, it will be positive. If x is less than 0, this term will also be positive. That means y square is positive. Okay. So the curve exists for x less than 0. Now this term, if a minus x is less than 0, then what will happen? Y square will be negative. That means if a is less than x, or we can say x is greater than a. That means for the value of x more than a, y square is negative. So the curve doesn't exist in the region where x is greater than a. Hence the curve exists in the region x is less than 0 and x is either equal to or greater than 0 or less than or equal to a. Now for the ease of convenience of plotting the curve, we'll find some points on the curve. Now this is the equation of the curve. Now the curve exists for the value of x less than 0. So suppose we have x is equal to minus a. Then y square will be minus a whole square into a minus minus a upon a, which is equal to a square into 2a upon a. So it is ultimately 2a square. So the value of y is plus minus a root 2. And suppose if x is a by 2, then what we have y square, we'll have it as a by 2 whole square into a minus a by 2 upon a, which on simplification gives y square as a square upon 8, which implies y is equal to plus minus a upon 2 root 2. So now, with the help of this information, what we have when x is minus a, y is plus minus a root 2. That means, suppose this is x is equal to minus a. Y is plus minus a root 2. The points are, this is plus a root 2, this is minus a root 2. Okay. When x is a by 2, y is plus minus a upon 2 root 2. So when x is a by 2, we have y as plus a upon 2 root 2. Suppose it is this point, and minus a upon 2 root 2, this is this point. Then the curve intersects the x-axis at 0, 0 and a0. That is the origin. 0, 0 is the origin and this is a0. It intersects y-axis at 0, 0. That is the origin. Then we know that at origin the curve has tangents. Y is equal to x and y is equal to minus x. And at a0 the curve has a tangent which is parallel to y-axis. Now with the help of this information we will draw a rough sketch of the curve. It will be as it like this. And we know that the curve is symmetric about the x-axis. So what we have in the upper half, the same we'll have in the lower half. So this is the rough sketch of the curve, which is the equation of which is given to us. The curve, it is symmetric about the x-axis. It intersects the y-axis at origin. It intersects the x-axis at origin and the point a0. It has got a tangent at the point a0 which is parallel to y-axis, and it has got tangents y is equal to x and y is equal to minus x at the origin. And the curve exists for x less than 0 and for the values of x when x is 0 up to x is equal to a. Thank you.